In March 2024, a Microsoft engineer noticed SSH logins were 500 milliseconds slower than usual. He didn't ignore it. What he uncovered was a 2-year operation to backdoor nearly every Linux server on Earth, hidden inside a compression library nobody had ever heard of. His name was Andres Freund. He wasn't hunting malware. Freund was a Postgres developer investigating performance. The logins were using more CPU than they should, so he ran valgrind. It complained about liblzma. Liblzma is the compression library at the heart of XZ, which is not where you expect an SSH problem to end up. What Freund uncovered became known as the XZ Utils backdoor. XZ Utils provides compression tools and liblzma, a library used throughout the Linux ecosystem. For years, much of the responsibility for maintaining it rested on one person, Lacia Colin. In 2022, Colin wrote publicly that XZ was an unpaid hobby project, and that his ability to keep up had been limited partly by long-term mental health issues. Whoever was behind this attack didn't only target code, they targeted the human structure around the project. Jia Tan, or GIT75 on GitHub, entered the XZ story in October 2021 with a harmless editor config patch. Then, in spring 2022, Jigar Kumar and Dennis Enns began pressuring Colin over slow merges and maintainership. Enns even referenced Colin's comments about his mental health. Meanwhile, Jia kept contributing. Whether Kumar, Enns, and Jia Tan were controlled by the same actor is strongly suspected, but it has never been proven. By June, Colin was describing Jia as practically a co-maintainer. By December, Jia had commit access. In March 2023, Jia tagged and built an XZ release. Jia had become someone trusted with the project's releases. In 2023, patches introduced a glibc feature called ifunc, which can influence function behavior very early during startup, legitimate on its own. Later, it became useful to the backdoor. On February 23, 2024, Jia Tan merged binary test files containing components of the payload. The next day, Jia released XZ 5.6.0. Malicious code was now inside a real release, moving through Linux distributions.
Just smile and wave, boys. Smile and wave.
The implant could interfere with SSH authentication and give the operator a path to bypass authentication or execute commands, including as root. But the full backdoor was not visible in the Git repository. The missing piece lived in the release tarball, the package distributions actually downloaded and built. The malicious build logic, build to host.m4, appeared in that tarball, but not in the normal Git source. The repository contained disguised payload pieces. The tarball contained the trigger that assembled them. On targeted x86-64 Linux builds, the malicious script reconstructed an object from hidden test data and linked it into liblzma. If INC helped that code run early enough inside the SSH server. OpenSSH normally has nothing to do with XZ, but on some distributions, it linked to systemd, which pulled in liblzma. So indirectly, a compression library ended up loaded inside the SSH server itself. The backdoor was passive, it did not call home. The operator had to send specially crafted authentication data through an SSH connection, signed with a specific ed448 private key. If the checks passed, the implant could bypass authentication or execute commands, including with root privileges, while suppressing or falsifying relevant log messages. Finding the backdoor wasn't enough, the operator also needed the private key. The design looked highly targeted, but no official attribution has been made, and the whole operation eventually collided with that same unexplained half-second delay. Valgrind pointed toward liblzma. He compared builds and found that the source he expected did not match the artifact being distributed. On March 27th, Freund contacted the Debian security team. 2 days later, he published his findings to the OS security mailing list. Red Hat issued an emergency advisory. CISA published an alert. Distributions began rolling packages back. The malicious XZ 5.6.0 and 5.6.1 releases had been available for about 5 weeks. They reached Debian Unstable, Fedora Rawhide, Kali Rolling, and OpenSUSE Tumbleweed. Stable RHEL, Debian Stable, and Ubuntu LTS were not affected. For once, staying on the boring stable release was a security feature. There is no confirmed public evidence that the attacker successfully used the backdoor against a real victim before discovery. The frightening part was how close it came to much broader production use. After disclosure, Jia Tan's GitHub account was suspended. Last Callin regained control of the project, and XZ 5.6.2 shipped without the backdoor. Jia Tan's real identity remains unknown, and no official attribution has been made. CSA later summarized the lesson in one sentence: "Next time, we may not be as lucky." The attacker did not begin with a traditional zero-day. The operation targeted something harder to patch, the maintenance model itself. It leaves a harder question: how do we build systems where critical infrastructure never rests on a single maintainer? 500 milliseconds were enough for Andres Freund to keep investigating. Had he dismissed them as noise, the backdoor might have remained hidden. And if stories like this are your thing, subscribe. We'll keep telling the real stories behind technology, the people, ideas, breakthroughs, failures, and engineering decisions that shaped them. See you in the next one.